Okay, now let us discuss exercise 1.3. Make correct statements by filling in the symbols, a subset or not a subset, in the blank spaces. So this is a symbol for subset and this is not a subset. First question is 2, 3, 4. The set consisting of the elements 2, 3, 4, and the other set is 1, 2, 3, 4, 5. So each element of this set is in the second set. So this set is contained in the second set, therefore we can say it's a subset. So this set is a subset. And the second question, A, B, C, and the second set is B, C, D. A is in first set but A is not in the second set, therefore we can say it is not a subset. So this symbol, not a subset. And the third question, X is a student of class 11 of your school and X is a student of your school. It's a subset. Clearly the class 11 belongs to the set of students of your school, therefore it's a subset. And the fourth question, X is a circle in the plane, X is a circle in the same plane with radii 1 unit. Circle in plane means it consists of all circles of any radii, but the second set says it's a circle in the same plane with radius only 1 unit. So it's a definite one, which is not, therefore the first set is not a subset of the second set. So it does not, it's not a subset. And fifth question, X is a triangle in the plane and second set is X is a rectangle in the plane. So set of triangles is not a subset of set of rectangle, therefore the set is not a subset of the second set. And sixth question, X is an equilateral triangle in a plane, X is a triangle in the same plane. So set of equilateral triangle is only a specific item, whereas set of triangle in the same plane is, it includes the equilateral triangle and all other triangles. It can be isosceles or it can be Celine triangle or it can be right triangle, any triangle, but equilateral triangle is one of them, so therefore it's a subset. So the set of equilateral triangle in a plane is a subset of the triangle in the same plane. And the last question, seventh question, subdivision, X is an even natural number, X is an integer. So even natural number is a part of the set of integers, therefore it's a subset. And second question, examine whether the following statements are true or false. So A, B is not a subset of BCA, it's false because it's a subset. So that statement is false. And A, E is a subset of X is a vowel in the English alphabets. Yes, it's true because the vowels in English alphabets are A, E, I, O, U. So A, E, the first set, also belongs to the second set. Hence, it's a subset. So it's true. And 1, 2, 3 is a subset of 1, 3, 5. It's false because 2 does not belong to second set. So that's false. And fourth question, set a singleton set A belongs to ABC. So it's false because the element A belongs to set but not the set belongs to set. So this symbol, look at the notation here, it given is belongs to. Belongs to means always you take an element belongs to a set, not a set belongs to another set. That you have to use a symbol subset. So it's false. And X is an even natural number less than 6 is subset of X is a natural number which is divisible by 36. So when you write in tabular form or roster form, even natural number less than 6 are 2, 4. But the natural number which divides 36 are 1, 2, 3, 4, 6, 9, 12, 18 and 36. Obviously 2 and 4 are the elements in the first set and they're also elements of the second set. Hence the set is a subset of the second set, so it's true. And third question, let A is 1, 2 and another set 3, 4 and 5. So which of the following statements are incorrect and why? So 3 comma 4 is a subset of A. No, it is because 3 is not an element, 4 is not an element, but a set containing 3 and 4 is an element. Therefore, you cannot say it's a subset. Okay, so it's incorrect since 3 comma 4 is an element of set A. So you can say the whole thing is an element of set A, not a subset. And second subdivision is 3 comma 4 is an element of A. That's true because 3 comma the set containing 3 comma 4 is an element of the set A. It's true. And another one is set containing an element is a subset. No, it's not true, because if you say an element A belongs to this, you have to say that it should be an element of that. So it is yeah, it's true, it's correct. So 3 comma 4 is an element, so a set containing the element is a subset, so it's true. And 1 belongs to A. The 1 is an element, therefore 1 is an element of A. That's correct. 1 belongs to A. It's true, and it's correct. And 1 is a subset of A. No, it's incorrect. You cannot say subset means it should be like enclosed within braces. An element enclosed within braces is a subset of a given set. So 1 is an element of A but not a subset. So it's incorrect. That's the reason. And the set of 1, 2, 5 is a subset of A. This it is correct because the 1, 2, 5 are all elements of set A. Therefore, you take a few elements from the set, it forms a subset. So it's correct statement. And 1, 2, 5 belongs to A. So it's incorrect because 1, 2, 5 is a subset, not an element. It's a set of elements. So it's a subset. And 1, 2, 3 is a subset of A. It's incorrect because 3 is not an element of A. That's the reason, because yes, an element 3, 4 itself together is an element of A, but not 3, but not 4. They are not elements of A. So it's incorrect. And empty set belongs to A. No, it's incorrect because the empty set is a subset of A, not an element of A. And empty set is a subset of A. That's correct. And the singleton set phi is subset of A. It's incorrect because phi is not an element of A. This is a symbol empty set. So empty set, either you write for empty set 2 braces without any element, or simply write phi. So this is what empty set is. But when you write something within the bracket, it means it's an element. So phi is not an element of A. And question number 4. Write down all the subsets of the following sets. So singleton set A given. Singleton set means a set containing only one element. Okay. So now you write subset, the set containing itself, because already we have seen the basic definitions. Any set itself is a subset of itself. So singleton set A, and empty set is also another subset of any set. Therefore, the subsets are singleton set A and empty set. And for second question, there are 2 elements A comma B. So write down all the singleton sets first. Singleton set A, singleton set B, then the set itself containing 2 elements, then empty set. So these are the subsets of the second set. And 1, 2, 3. So write down all the singleton sets first. Singleton set A, 1, singleton set B, 2, singleton set 3, then a set containing 2 elements. So 1, 2, and the subset 1, 3, and the subset containing 2, 3, and the subset containing all the elements. The set itself is a subset. It's a subset of itself. So 1, 2, 3, and the empty set. So you can have so there is a formula. If an element has n of A is m, then n of p of A is 2 power m. So here the set of elements is 3, therefore power set, number of subsets is 2 power 3 is equal to 8. And fourth question, empty set. So empty set there is no subset, only empty set. And write the following as intervals. Okay, so -4 strictly less than x less than or equal to 6. So curly bracket means it's an open interval, which means the limit, the end point is not included. Square bracket means the end value or the limiting value is included. So therefore, in interval form, if it is strictly less than means it's not included. So -4 open bracket minus comma, and less than or equal to means 6 is included, so square bracket. So this means open, it means closed. Open means that value is not included, closed means the value is included. So -12 less than x less than -10. So both the values are not included, so to put an open braces. So that is open bracket -12 comma -10. And third question, 0 less than or equal to x less than 7. So 0 is included, so put a closed bracket, the square bracket 0 comma 7. 7 is not included. So that means, say for example, a comma b means both a and b are not included. It is a less than x less than b. When I say a comma b square bracket, that means a less than or equal to x less than or equal to b. Both the values are included. So this is open braces, this is closed bracket. So this is open, we call it as open, and this is closed. So here 3 less than or equal to x less than or equal to 4, so both the values are included. So you write a square bracket, so they are closed bracket. So closed interval 3 comma 4. Question number 6. Write the following intervals in set builder form. So open bracket, open interval -3 comma 0. First question. So set of all x such that x belongs to real numbers and x lies between -3 and 0, that is -3 less than x less than 0, because it's an open interval. -3 and 0 not included. And second question, 6 and 12 both the values are included. It's a closed interval, so 6 and 12 both included. So therefore set of all x belongs to real numbers, 6 less than or equal to x less than or equal to 12. That means 6 and 12 are included. And third question, 6 comma 12, where 6 is open and 12 is closed. That means 6 is not included, whereas 12 is included. Therefore set of all x's such that x is real, x belongs to R, and 6 less than x less than or equal to 12. And fourth question, -23 comma 5, whereas -23 is included, 5 is not included, so open interval. So you can say that set of all x such that x belongs to R and -23 less than or equal to x less than 5. So if the number is included square bracket, you write less than or equal to. If it is open bracket curly bracket, then it is less than, there is no equal to, the number value is not included. So what universal set would you propose for each of the following? Question number 7. The set of right triangles. So obviously set of right triangles is a part of a set of triangles. Therefore the universal set can be a set of triangles, or you can say set of polygons. Polygon means many-sided figures, so it can also say like that. So it can be either a set of triangles. Triangles included, there are different types of triangles: equilateral triangle, isosceles triangle, Celine triangle, right triangle. So right triangle is a part of it. So therefore you can say the universal set of right triangles is set of triangles. And question number 2, set of isosceles triangles. Once again the same thing, isosceles triangle is a part of set of triangles. Therefore universal set can be a set of triangles or a set of polygons. And question number 8, given the sets A equal to 1, 3, 5 and set B is 2, 4, 6 and C is 0, 2, 4, 6, 8. Which of the following may be considered as a universal set for all three sets A, B and C? So you have to find a universal set which contains all these elements. So when you consider first question, 0, 1, 2, 3, 4, 5, 6. But when you look at the C, here 8 is there in set C, but 8 is not here. So this is not a universal set. Empty set is not a universal set. And third one is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So when you see that, you get all the elements. Set A has 1, 3, 5, you have 1, 3, 5. And set B has 2, 4, 6, you have 2, 4, 6 here. And set C is 0, 2, 4, 6, 8. 0, 2, 4, 6, 8. So it has all the elements of all three sets. Therefore, this can be the universal set. Of course, we can also consider fourth question. We'll see that obviously 0 is not here. So 0 does not belongs to this set. Therefore, it cannot be a universal set. So the third subdivision is the universal set of all given sets A, B, C. Okay. Because A is contained in this set, B is also a subset of this, and C is also a subset of this. Therefore, it is a universal set. Okay, that completes the answer for this exercise.